when we are dealing with a large number of data and interested in identifying some pattern from this data and make use of this pattern for our future work. It is almost impossible for a human to do it because the size of the data, volume of the data, variety of the data is so much that manually it is impossible. So we need our machine to do this work. Instead of writing the code to the machine and make it solve our problem, it is easier to make machine understand our problem and solve the problem we are having. That is, instead of we coding, if we can make machine to understand our problem and can solve our problem, it would be the best. That's basics of machine learning. Instead of programming the machine, we make machine to learn the way humans learn to solve the problem. We do make machines to learn how to solve the problems. So we just submit the problem to the machine. Let the machine decide what the problem is, how the problem can be solved, and let it come with the solution. So that's what we call machine learning. It can be done at a very basic level. So we can write every code for creating this machine learning algorithms. But doing that is again a waste of time because we can't go to the level we wanted to, because we would like to have a lot of abstraction so that the human efforts can be minimized. So there comes again tools that help us in making machine understand our problem. So the way we can express our problem to the machine, we would like to simplify that further. So for that we have many machine learning tools. When it comes to data, then we have data in the form of multi-dimension, because the data which we are talking of today is comprising of multiple columns. The attributes are in terms of hundreds or thousands. Therefore, it is better to put that in the form of some easier data structure, and the best data structure we can think of is a tensor. Tensor with a 0 dimension is a scalar, tensor with 1 dimension is a vector, tensor with a 2 dimension is a matrix, and that way in general when there are n components in our system, then we would like to work with the n dimensional system, and we do require tensors to work with. The TensorFlow is an extension of Python, and that will provide many tools to work with higher dimension systems, be it capturing the data, be it cleaning the data, be it modeling the system, or predicting it, analyzing it, visualizing it. So for many purposes, TensorFlow comes to our aid. With TensorFlow, very big problem can be solved in few chunk of code. That's a advantage of working with TensorFlow. Then we later realized that once one problem is solved, if you look the problem with a little different perspective, it may lead us to solution for some other problem. That's a foundation for Keras. That's a layer which is above the TensorFlow. TensorFlow basically was a layer above the Python, and above Tensor layer, TensorFlow, we have Keras. Keras is one which has ready-made models available with it, so we don't need to make the whole model created for the current problem. Any solutions which are already available can be reused to solve our problem with minor changes, and such many issues are there which Keras can help us. So that's another thing. When it comes to working with a large amount of data, then scikit-learn comes to our aid, whether it is cleaning the data, whether it is learning the insight of the data, or creating a model, predicting the model, understanding performance of the model, and all details. So yes, from the data cleaning to visualization, model building, everything, the scikit-learn has got the various tools. So scikit-learn can be one of the best tools when we begin working on machine learning. Theano is another such tool which helps us in making even higher abstractions. PyTorch is another tool we have. Same way we have H2O.ai, specifically meant for artificial intelligence. Then we have DL4J, so this data learning, deep learning for Java. So that's an extension of Java we have. Then we have the XGBoost, other tool we have. So many tools we have which are available today to use, and through these tools the work of a human being has reduced to almost negligible. We just need to know what are the various tools available for the current problem. Just make use of that tool. So 99.99% of the work is taken care by these tools if you are good at remembering what tool is available for what problem solutions and all that. So that's the things we need to look at when we are working on ML tools. So we do see in detail each of these tools and how they contribute in simplifying our work while solving bigger and bigger problems. So these tools will help us to make a higher abstraction possible, and will allow us to solve bigger and bigger problems with least efforts. Most of the efforts are now taken care by these tools. A human effort has come down to almost negligible. So we'll see them in detail. So please keep watching. Thank you.